Today we are doing composite function. Now, because in mathematics, you can't just solve mathematics. You have to understand the concepts of everything in mathematics. So that's why I gave out the concept of this composite function. So in calculus, composite function is also called function of a function. So from the word to compose means to put something inside something. So that's why we call it function inside a function. So we call it composite function. It is not direct like that of first principle and second principle. So it has been composed. So you cannot differentiate it direct. You have to use the principle of composite function. Now, the principle of composite function says that whenever a function is inside a function, like e.g., f of x equal to 2x squared plus 4 all squared, which means this occurs 2 times. So this has been composed in 2 times. So we call it composite function. Example again, y equal to tan 3x. So 3x has been composed. So it is not standard. It has been in form of function in a function. Look at this also. F of x equal 3x minus 4 raised to the power of half. It has been composed. So the only way to solve this is using chain rule. We are going there. So all these, they are all composite functions. Composite functions. So now, example, find the derivative of the following functions. We want to find the derivative, which means dy over dx of these functions. How can we find the derivative? So it's not hard. But for composite function, the standard method is chain rule. We call it chain rule. So let's go. Number 1, let's go. For number 1, the question is y equal to 5x squared minus 3 all raised to the power of 3. So solution, y equal to 5x squared minus 3 all raised to the power of 3. Now, how can we find the derivative? We want to differentiate this question now. How can we do that? It is not hard. But we have to use the principle of what? Chain rule, because it is a composite function. According to chain rule, let me give out the concepts. So according to chain rule, we will now say that because it has been composed, we say let the function itself, leaving the power, just leave the power. Let what? U to represent the content in the function, which is what? 5x squared minus 3. So we are making use of u as all the things. We are representing 5x squared minus 3 as u. So which implies that y will now be, since everything here is now u, it will now be u raised to the power of 3. So we are representing 5x squared minus 3 as u raised to the power of 3 in this function now. So from this u, we can generate du over dx. Since our u is now 5x squared minus 3, I will now differentiate u with respect to x. If I differentiate u with respect to x, this one will give me 10x from second principle. That is 2 times 5, 10. Remove 1, that is what? 10x. Then from this y, since y is u cubed, we can generate dy over du. We will differentiate y with respect to u. It will now give us what? 3u squared. According to chain rule, our final answer, therefore, our aim is dy over dx. Don't forget. So dy over dx will now be equal to dy over du times du over dx. As you can see, dy over du is what you got here, then du over dx is what we got here. As you can see, if du cancel du in this formula, it will give us dy over dx. So it makes sense. So dy over dx, what is dy over du? We have what? 3u squared times, what is our du over dx? 10x. 10x. So in conclusion, dy over dx, 3 times 10, that is 30 what? 30x u squared. But don't forget, you are given question in form of x, not in form of u. You will now recall. We call it recall. Recall that. You now recall that what? Initially you said let u to be this. So you now substitute your u back into the final answer. Recall that u equals to what? 5s squared minus 3. So in conclusion, we cannot conclude the final answer here that dy over dx, the final answer, is equal to 30x bracket u is what? 5s squared minus 3. 5x squared minus 3. And there is square here, all squared. That is the final answer for dy over dx for this composite function question.